If you're working in any kind of industrial setting, you know that some of the most critical pieces of kit are the ones operating under pressure. But with that power comes some very real risk. So today, we're going to break down exactly what those risks are and, more importantly, lay out a clear strategy to keep them under control. Let's just start with this, because it really gets to the heart of the problem. A pressure vessel can seem perfectly fine for years and years, and then, in an instant, it can fail. Violently. We're not talking about a slow leak here. We're talking about a sudden, catastrophic event. And the reason why it's so violent, well, that's what we're talking about next. Here it is, the invisible threat. It isn't just the pressure itself, it's the incredible amount of stored energy packed inside that equipment. The best way to think about it is like a giant, tightly wound spring. As long as the casing is strong, everything's fine. But if that casing breaks, all of that pent-up energy is released at once. And that release is, for all intents and purposes, an explosion. Okay, so what are the triggers? What are the specific things that can cause that catastrophic release of energy? Let's dive into the main technical risks that you absolutely have to have on your radar. First up is the most obvious one, overpressure. This is pretty much what it sounds like. The pressure inside the equipment simply gets higher than what it was built to handle. Maybe it's a runaway chemical reaction, maybe an outlet gets blocked, or a control system just fails. Whatever the cause, the result is the same. The vessel is stressed way beyond its limits. Then you've got corrosion. This one's the silent enemy, because it can happen so slowly you don't even notice it. It can eat away at the metal from the inside out or the outside in, thinning the walls of the equipment year after year until one day it's just too thin to hold the pressure. You know, sometimes the problem is baked right in from day one. Tiny, almost invisible flaws in the welds, the seams holding the whole thing together, can become huge problems. Under pressure, these little defects act as starting points for cracks, and a small crack can lead to a total rupture. And just like anything else, materials get tired. Think about it. The constant cycles of pressure going up and down, temperatures changing, that all takes a toll. Over years and years of service, the metal itself can become brittle, it can weaken, and eventually lose the strength it needs to do its job safely. This is a huge one. Your safety valve is your absolute last line of defense against overpressure. It's the whole point. But if that valve is blocked, or it's corroded shut, or it's just set up wrong, it can't do its job. When your final safeguard is gone, a dangerous situation can become a disaster really, really fast. And finally, we've got to talk about us, the people. Running equipment outside of its designed limits, whether that's for temperature or pressure, or making changes to it without proper authorization, that's just a recipe for disaster. This equipment is only safe when we use it exactly how the engineers intended. So we've walked through the causes, all the technical things that can go wrong, but what happens when they do? What are the real-world, on-the-ground consequences of one of these failures? Well, the fallout is it's severe, and it goes way beyond the initial blast. Of course, there's the immediate and tragic risk to people's lives. But on top of that, you're looking at millions in damage to equipment, a total production shutdown that could last for months, and a major environmental impact. And at the end of the day, all of that comes back as massive legal and financial liability for everyone involved. Okay, that was all pretty grim, I know. But here's the good news. These risks, as serious as they are manageable. So let's shift gears and talk about the solution. Let's talk about a proactive, systematic prevention strategy. Here's your 5-step game plan. It all starts with step 1. You have to know what you have. Identify every single piece of pressure equipment on your site. Step 2, you need a plan, a real comprehensive inspection plan. Step 3, maintain those safety valves. Remember, they're your last line of defense. Step 4, you have to inspect. That means regular visual checks and using advanced methods like NDT to find those hidden flaws. And finally, step 5, you absolutely have to train your people. Everyone who works with or near this equipment needs to know the risks and the procedures. These 5 steps are non-negotiable. And look, this whole strategy, it doesn't just exist in a vacuum. You're not making this up as you go. It has to be built on a rock-solid foundation of strict adherence to industry codes and regulations, like ASME, PED, API, and whatever your national rules are. These standards are there for a reason. They save lives. Following them isn't optional. It's what being a professional is all about. So when we pull all this together, what's the big takeaway?
how should we really be thinking about the relationship between what we do every day and the inherent risks of pressure?
This right here, this is the core message of this entire explainer. The danger isn't baked into the steel itself. The danger comes from a failure to manage the risk, a failure to control that incredible stored energy. With the right systems in place, with the right knowledge, and with the right discipline, these powerful tools can and are operated safely every single day. It all comes down to control.
Mastering that control is a journey. It's an ongoing process. So if you want to keep deepening your knowledge on safety, inspection, and standards, make sure you subscribe to the Pressure Equipment Academy for more expert content. Thanks for watching.